The second part of section 1.8, our goal is to talk about composite functions, or the composition of functions. The composition of the function f with the function g can be written as f circle g of x. This is our notation for a composite function. What this means is that we want to take the function g of x, the second one listed here, and plug it in as the input into f. So if we want to evaluate something like this, we could plug in a value for x into g of x, find the output, but then that output would become the input for f. So for example, we've got f of x equals 3x plus 6 and g of x equals x squared minus 2. Our goal is to find f of g of x. This is going to give us another function. This is not us evaluating anything. So f of g of x is equal to f with g of x plugged into it. So wherever we see an x inside the f function, we want to go through and plug in g of x into it. This is going to end up giving us 3 times. Now normally here we would put in x, but now we're putting in g of x. And g of x is equal to x squared minus 2. F of x also has a plus 6 tacked on to the end. We can now distribute, which ends up giving us 3x squared minus 6. And we still have the plus 6 tacked on to the end, which ends up giving us a solution of 3x squared. Now here, in the next problem, when we go through and find f of g of 3, we have two options. As mentioned above, we could plug 3 into g of x and evaluate, then plug in that solution into f of x for x and evaluate. However, the easier process, now that we've found f of g of x, is just to plug into 3x squared, the value 3. So f of g of 3 is equal to 3 times 3 squared. Again, we're plugging in the value 3 for x, in for x from above. We square first. 3 squared is equal to 9 times 3 gives us 27. Before you go on to the next section, make sure that you attempt to find g of f of x and g of f of negative 1, and then I'll show you how to get the solution to those.